Hello everyone, welcome back to the channel. Today we are diving into one of the most important concepts in machine learning: train, test and validation data. Whether you are a beginner or just need a refresher, by the end of this video you will understand why splitting your data is crucial for building reliable machine learning models. Let's get started. Before we train any machine learning models, we need to split our data into three key subsets: train data, validation data, and test data. But why do we do this? Well, it is all about making sure our model does not just memorize the data, but actually learns to generalize and make accurate prediction on new and unseen data. Let's start with the training dataset. So this training dataset is used to train the model. So the model learn parameters using this dataset. Typically, it is around 60 to 80% of the overall data is used for training. And what it does, it learns the relationship between features and target. Target means the label you are putting, adjusting model weights and parameter. But obviously there are some challenges. So first of all, we must be representative. So we need to present a dataset that must be representative of the problem space. That means the training dataset should contain all the variabilities of a specific problem. And it needs sufficient examples of all classes and difficult scenarios. So during training, the model uses algorithms like gradient descent to minimize errors and improves its prediction. But here's the catch: if you only use training data, your model might overfit, meaning it performs well on training data but fails on new data. That's where validation data comes in. So in validation dataset, we typically use 10 to 20% data for validation purpose. And the main goal or purpose of using validation data is to tune the hyperparameter and prevent overfitting. So we can use it to select optimal model complexity. We can select it for early stopping, means how many epoch we need to learn the training. Then we can optimize the hyperparameters such as learning rates. And also we can test on different different model architecture, and select the optimal model for a specific problem. And here is one key point, that this validation data set is never used to learn the model parameter directly. So the actual importance of validation dataset, you can think of it as a fine-tuning of your model to make sure it is really good for the real world. Without validation data, you are essentially flying blind. Next, we have test dataset. So in test dataset, typically we use 10 to 20% data for testing, and this test data is used for final evaluation of the trained model. And the golden rule is that you only use this test data once at the end of your model development. And the importance Obviously, it provides unbiased estimation of model performance because when you are training the model, it never sees the test data. So the test data is an unseen data and completely new data for the model. Next, let's talk about the reason of this data split, why we actually need to split the data. So first reason is to prevent overfitting. So we need to make sure the model does not memorize the training data, but it learns from the data and generalized well. Second, we need an unbiased evaluation. So this test data provide an unbiased assessment of the model performance. And third reason is that we need to tune our hyperparameter. And here comes the validation dataset. Validation dataset helps optimize model parameter for better performance. Let's see an example how we can practically split the data. So first, when we got a dataset, we can split it into training and testing. Let's say for this example, we use 80% for training and 20% for testing. Then from this 80% of training, we can further divide it into training and validation dataset. So we can do it like again 80-20. So among the 80% of the overall data, we use the four part out of 5 for training and 1 part for validation. We can use it also in cross validation method. I will talk about cross validation method more about in the next slide. So let's see an example. For example, we have 1000 sample of a data set. So first we split it into 80-20. That means 800 for training and 200 for testing. Then we can again validate this 800 into 80 and 20. This time we can use 160 for validation and rest of the 800, which if I do the math right, which is 640 samples for training. So this is a practical example how we split the data. Let's come with the cross validation technique, which is a very powerful technique for prevent overfitting and generalizations. So what it does, first of all, it split the test and training. So test is completely different, separated. It will not use in training. But the training dataset is further splitted into different section. Let's talk about K-fold cross validation first. This K means how many fold you want. For example, if I divide it in 5 folds as shown in this example slide, here you can see the first fold, which is marked as red, is considered for validation, and rest of the 4 fold is used for training the model. And we can repeat this process 5 times. So in the second iteration, we can use the second fold for validation and rest of the data for training. And similarly, you can move forward and use the third fold for validation and so on. So this ensures that in your training dataset, we used all the data by turn for validation and fine-tune our model. And there is another method which is also called leave one out cross validation method. In terms of using a fold, we can leave one out one data point from the dataset and use rest of the dataset for training the model. This model is this leave one out cross validation is more powerful, but it also need more computational power. That means it computationally expensive, but less, it put less bias on top of it. Another type of cross validation is that leave one out group cross validation or leave one out subject cross validation, which is also used in medical field, especially because they want to leave one subject or a patient out of the data set, and then train the model and validate with the patient which is leave from the data set. So this ensures that when a new patient comes, so the model does not see the new patient data, so that it can learn or train itself using those available patient data. So this is very common in biomedical field as well. And the third type of cross validation I like to tell, it is called Stratified K-Fold validation, which is used in imbalanced data set. So it used to maintain the class distribution for each fold equally, and this is very ideal for imbalanced data sets. So we can see many data set does not have equal number of sample for each classes. So we use this type of cross validation, this start field cross validation in those type of imbalanced data set. Okay, so let's talk about what are the best practice in terms of machine learning model development. So first of all, we need to plan. So we need to plan ahead. So plan means how you will split the data. So data splitting strategy must be planned ahead of your model development. Second, you need to ensure the splitting are representative of the overall data distribution. That means that when you distribute in training, validation, and testing data set, all these splits can represent all type of classes and variation among them. Third, keep test data completely separate until the final evaluation. Fourth, you need a proper documentation. So document your splitting methodology for reproducibility. Fifth, consider domain specific requirement, like as I said, in biomedical field, maybe you need to separate the patient data from each other, or sometimes group data or time independence data. So you need to consider this. And sixth, the use stratification for imbalanced data set. Those are the 6 best practice in machine learning model development. Let's wrap up. So what are the key takeaway from these slides? First of all, the proper data splitting is fundamental to reliable machine learning models. Training data teaches the model, validation tunes it, and test evaluates it. Different problem may require different splitting strategy, so you need to be more cautious about that. If you want to learn more about data splitting in machine learning, you can go through the scikit-learn documentation on model evaluation, cross-validation techniques, and even data leakage prevention strategies. Thank you for listening. Hope to see you on the next video.